Something happened at the moon. Not metaphorically, not theoretically. Something that the world's most sophisticated space agency confirmed, and then buried so deep inside technical reports and academic journals that the average person will never find it. NASA's Artemis program just pulled back the curtain on a body that has orbited Earth for 4.5 billion years, and what they found underneath its surface rewrites every assumption you ever had about our closest neighbor. The moon is not what you were taught. It never was. And what comes next will change the future of every human being on this planet. There's a question that no mainstream outlet is asking. It is not about politics. It is not about celebrity. It is about the single most significant discovery happening right now in human history, one that is unfolding 238,000 miles above your head on a world that has watched every civilization rise and fall from the same unchanging distance. The question is this: what is actually hidden beneath the surface of the moon? And why did it take humanity over 50 years to go back and look? That silence is not an accident. And the answer, now slowly emerging from the data of NASA's Artemis program, is more extraordinary than anything the public has been told. Let's begin with what you think you know. For decades, the moon was treated as a conquered territory. Apollo planted the flags. Armstrong took the steps. Scientists collected the rocks. And then, for half a century, the most powerful space agencies on Earth essentially looked away. Budgets were redirected. Mars captured the imagination. The moon was quietly demoted from destination to backdrop. A pretty object in the night sky that humanity had already figured out. That narrative was comfortable. It was also dangerously wrong. Scientists have been sitting on a deeper truth. We don't even know whether the moon has a solid core or a liquid core. Read that again. After 12 Apollo missions, hundreds of billions of dollars in space exploration, and 50 years of orbital observation, the most fundamental question about our moon's interior remains unanswered. As one lunar geologist put it plainly, does the moon have a solid core or a liquid core? We still don't know. That is not a minor gap in knowledge. That is a gaping wound in our understanding of the solar system itself. And it is precisely why what Artemis is now revealing matters so much more than anyone is saying out loud. In April 2026, Artemis II launched on a nearly 10-day voyage around the moon, marking the first crewed flight of NASA's Orion spacecraft, with astronauts Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen aboard a capsule they named Integrity. 4 human beings flying deeper into cislunar space than any crew since the Apollo era. And what they saw when they looked at the moon from that vantage point was not what the textbooks had prepared them for. The Artemis II crew captured imagery of the moon coming into view along the terminator, the boundary between lunar day and night, where low-angle sunlight cast long, dramatic shadows across the surface, accentuating rugged topography, revealing craters, ridges, and basin structures in striking detail. Features that, from orbit, began to tell us a story the surface had been hiding for billions of years. The story doesn't begin with Artemis II. It begins at the bottom of the moon, at a place called the South Pole Aitken Basin. The South Pole Aitken Basin lies on the moon's far side and ranks among the oldest preserved structures in the entire solar system. Scientists call it the SPA Basin. It is approximately 1,600 miles wide and more than 5 miles deep. To put that in perspective, if you drop the entire continental United States into this crater, it would fit with room to spare. It is so ancient, so enormous, and so violent in its origin that researchers believe the impact that created it didn't just scar the surface. It may have punched all the way through the crust and into the deep interior of the moon. Because of its immense size and age, scientists view it as a unique record of the moon's early history. The collision struck the lunar surface with such force that it may have excavated material from deep inside the moon, including portions of the lunar mantle, the deep interior layer that no probe has ever directly sampled. Material from a geological depth that, on Earth, we can only access through volcanic eruptions and tectonic forces that have been operating for billions of years. On the moon, that material may be sitting on the surface, scattered across the basin floor, and Artemis astronauts are being targeted to land directly adjacent to it. Scientists from the Center for Lunar Origin and Evolution at Southwest Research Institute have helped uncover new details about the formation of the moon's oldest and largest impact crater, providing fresh insight into what future Artemis astronauts could encounter near the lunar South Pole. 2 complementary studies determined that the SPA's surrounding area contains mantle-derived rocks, offering information about the interior of the moon in its earliest history. Proposed landing sites for upcoming Artemis missions lie within the region, allowing astronauts access to study these materials. Let that sink in. The landing sites chosen for Artemis are not arbitrary. They have been selected with a specific scientific agenda to place human hands on rocks that may have come from the deep interior of a world that formed more than 4 billion years ago. These are not surface rocks. These are not samples of lunar dust. These are potential fragments of the moon's hidden engine, geological evidence from a layer of this world that has never been touched, studied, or even seen directly until now. But here's where it gets worse, or perhaps more accurately, more complicated. The scientific community is cautiously electric about what lies beneath the SPA basin, but the true shock comes not from what has already been found. It comes from what the research predicts is still down there, waiting. If mantle rocks prove to be riddled with byproducts of radioactive decay, it would probably mean the moon's interior is richer in heat-generating radioisotopes than scientists had thought, thus explaining why it's still convulsing long past its geological expiration date. The moon, which was long considered geologically dead, may still be generating internal heat. It may still be experiencing geological processes. And those processes have a name that sounds almost harmless until you understand its implications: moonquakes. The moon shakes. It has always shaken. Apollo seismometers first detected moonquakes in the 1970s, and for decades the data sat largely unanalyzed because the moon was considered finished, geologically expired, scientifically irrelevant. But now, with Artemis preparing to return to the surface, researchers went back to those old seismic recordings. And what they found there has completely reoriented the mission priorities of an entire space program. A new study published in Science Advances on July 31, 2026, suggests that seismic waves generated by moonquakes can reveal hidden deposits of water ice buried beneath the permanently shadowed craters of the lunar South Pole. Scientists are not drilling for this ice. They are not sending cameras underground. They are listening. Using the vibrations of the moon itself, the tremors generated by ancient geological forces, as a kind of sonar, bouncing signals through layers of rock and ice to map what lies beneath without ever breaking the surface. This is not science fiction. This is operational science happening right now. Researchers from the University of Maryland, Lawrence Berkeley National Laboratory, and the University of Hawaii found that seismic waves, the same type of vibrations scientists measure during earthquakes, can reveal the presence of buried ice by the way those waves bend and reflect when they encounter it. Water ice changes the acoustic signature of the moon. It creates a detectable distortion in the seismic wave pattern, a fingerprint that says, here. Beneath this layer of rock and ancient dust, frozen water has been sitting undisturbed for potentially billions of years, and this is where the story stops being about science and starts being about power. Water on the moon is not a curiosity. It is not a footnote in a geology paper. For astronauts, that ice could serve several critical purposes. Once melted and purified, it could provide drinking water. Electricity could also separate it into oxygen for breathing and hydrogen for rocket fuel. A reliable local supply would reduce the amount of material that future missions need to transport from Earth. Do you understand what that means in strategic terms? The nation or coalition that controls the water ice deposits at the lunar South Pole controls the fuel supply of the next era of space exploration. The moon becomes not just a destination, but a refueling station. A strategic node in a geopolitical game that is being played right now, with missions, seismometers, and landing site selections as the opening moves. The stakes are not hypothetical. They are being measured in mission timelines and national budgets. Research has shown that permanently shadowed regions near the north and south lunar poles could hold water ice, as well as scientific riches. On the moon, there is no air pressure to hold liquid water together. It explosively vaporizes. There are only two forms in which water can last under the harsh lunar vacuum, either locked in minerals or as rock-hard ice. The polar craters are the exception. Permanently shadowed, never touched by sunlight, their floors sitting at temperatures almost 3 times colder than the coldest recorded day in Antarctica. Inside those frozen, lightless vaults, water ice has been accumulating for billions of years, delivered by comets, asteroid impacts, and the solar wind itself, building up in layers, compressing, preserving, a reservoir not just of water, but of ancient chemistry, of molecular history from the early solar system, of answers to questions that cut to the heart of how Earth's oceans formed. What most people are not seeing is that the moon may hold the origin story of life itself. The water on Earth, the water in your body right now, may share a chemical signature with the ice locked inside those lunar craters. If the moon and Earth were bombarded by the same comets in the same early period of solar system history, then the hydrogen and oxygen frozen beneath the lunar South Pole may be isotopically identical to the water in Earth's deepest oceans. Finding and analyzing that ice would give scientists their most direct window yet into the molecular events that made Earth habitable. This is not about going back to the moon because it is a nice place to visit. This is about the moon holding the receipts of creation, and Artemis being the first mission capable of actually reading them. But the geopolitical dimension of this cannot be overstated, and it is here that the narrative becomes genuinely alarming. China's Chang'e 7 mission, scheduled to land near Shackleton Crater in late 2026, will carry a seismometer capable of recording lunar vibrations in one of the regions considered most promising for buried ice. China is not going to the moon because it loves science. China is going to the moon for the same reason America is accelerating its Artemis timeline at a pace that, just 18 months ago, would have seemed impossible. The race is on, not just for flags and footprints, but for water, for resources, for the strategic high ground of cislunar space, and the decisions being made in laboratories and mission control rooms right now will determine who controls that high ground for the next century. NASA announced it is increasing its cadence of missions under the Artemis program to achieve the national objective of returning American astronauts to the moon and establishing an enduring presence. This includes standardizing vehicle configuration, adding an additional mission in 2027, and undertaking at least one surface landing every year thereafter. One landing every year. That is not the schedule of a program committed to scientific curiosity. That is the schedule of a program committed to territorial consolidation. And NASA continues to target the first Artemis lunar landing in early 2028, when crew will transfer from Orion to a commercial lunar lander for transportation to the surface. The window is closing faster than anyone in the public conversation seems to realize. Here is the full picture assembling itself layer by layer. The Artemis program is not a nostalgia project. It is not Apollo 2.0 for sentimental reasons. It is a geopolitically driven, scientifically urgent resource acquisition operation dressed in the language of exploration. The moon is the most important piece of real estate in the near solar system, a platform from which any actor with permanent presence can project, influence, monitor activity, control communications, and refuel spacecraft heading deeper into the system. And beneath its surface, 3 separate categories of discovery are now converging simultaneously in a way that no single news headline is capable of capturing. First, the mantle rocks of the SPA Basin. Researchers used advanced computer simulations to recreate the ancient impact that produced the SPA Basin, and the resulting models suggest that the collision excavated material from deep inside the moon. This is geological gold. Samples of the moon's mantle would allow scientists to test the most fundamental theories of planetary formation, including the leading hypothesis that the moon itself formed from the debris of a catastrophic collision between early Earth and a Mars-sized protoplanet called Theia. If mantle rocks carry a chemical signature consistent with that collision, it would confirm the origin story of the Earth-Moon system. If they don't, if the chemistry is wrong, then everything we think we know about how our world formed goes back on the table for revision. Second, the water ice deposits. NASA is joining international partners to hunt for ice on the moon in support of future human exploration. The agency is providing a water-detecting instrument called the Neutron Spectrometer System to the Lunar Polar Exploration Mission led by JAXA and ISRO. The instrument, which detects ice under the lunar surface, will be installed on a lunar rover planned to arrive at the moon no earlier than 2028. Multiple nations, multiple instrument packages, multiple missions converging on the same target zone. The south pole of the moon is about to become the most scientifically monitored piece of real estate beyond Earth, and whoever lands there first with the capability to extract, process, and store that water will have established a foothold that transforms every mission that comes after it. Third, the seismic revolution. With LEMS's 2 seismometers, the team hopes to learn the structure of the local crust and mantle and gain unprecedented insight into the moon's evolutionary history, as well as the intricacies of planetary formation. Artemis III is the Apollo 11 of our generation, as one researcher described it. The Lunar Environment Monitoring Station, a SPY seismometer package roughly the size of a carry-on airplane suitcase, will be deployed by astronauts during a moonwalk and left to listen, to record the tremors and vibrations of a world in geological conversation with itself. The data it returns will be the first continuous, high-resolution seismic record of the lunar interior from the South Polar region. It will tell us not just about ice, but about the deep structure of the moon's crust and mantle, in ways that have never been measured from the surface. And what that data reveals may force a complete rewrite of the scientific models that have defined lunar science for 50 years. The moon may be far more geologically active than anyone assumed. Moonquakes, which at their strongest can persist for hours, could imperil a future moon base. This is a detail that appears in scientific papers and then quietly disappears from public discussion. Hours. A moonquake can last for hours. Far longer than the typical earthquake, because the moon lacks the water and tectonic structure that dampens seismic energy on Earth. The ground shakes and keeps shaking, and the waves bounce back and forth through the rigid lunar interior for far longer than any lunar base architect would find comfortable. This creates an engineering challenge of considerable magnitude, and it means that the geology of the moon is not just a scientific question. It is a survival question for every human being who will ever try to live there. According to informed sources in the scientific community, the selection of Artemis landing sites near the SPA basin was not simply about being close to interesting rocks. It was about triangulating three simultaneous priorities: proximity to potential water ice, access to ancient mantle-derived material, and placement in a region where seismic monitoring can provide the most complete picture of the lunar interior. The missions are scientifically layered in a way that the public announcement rarely communicates. Each instrument, each landing site, each orbital pass is part of a systematic effort to answer three distinct but deeply connected questions at once. Where's the water? What is the moon made of at depth? And is this world geologically stable enough for permanent human presence? The real story is that NASA is not just exploring the moon. NASA is conducting a site survey for civilization, and the timeline reveals the urgency. Artemis II finished on April 10th, 2026, taking humans the farthest they had ever been in space, a crewed test flight beyond the moon. The hardware is proven, the trajectory is validated. The crew demonstrated that human beings can survive the deep space radiation environment beyond low Earth orbit and return safely. That is not a small thing. That is the first confirmed proof of concept for sustained human presence in the space beyond Earth's protective magnetic field. Every Artemis mission after this one builds on that validation. NASA continues to target the first Artemis lunar landing in early 2028, in which crew will transfer from Orion to a commercial lunar lander for transportation to the surface of the moon. 2 years from now, human beings will be standing at the lunar South Pole. They will be walking on terrain that has not felt a footstep in geological time immeasurable. And beneath their boots, beneath the ancient regolith ground into powder by billions of years of micrometeorite bombardment, lies ice, lies mantle rock, lies a seismic record of planetary formation stretching back to the earliest moments of the solar system. What those astronauts find when they deploy their instruments and collect their samples will determine the scientific narrative of the next generation. But what governments do with that information, who controls the resources those findings reveal, and who establishes the infrastructure capable of extracting them, who plants the equivalent of a permanent flag in the most scientifically and strategically valuable terrain on the moon, that will determine something far larger than any single scientific paper can contain. What most people are not seeing is that the moon has already become a geopolitical theater. China's Chang'e 7 mission is scheduled to land near Shackleton Crater in late 2026 and will carry a seismometer with several suspected ice deposits located nearby. The timing is not coincidental. Shackleton Crater sits at the very edge of the South Pole's permanently shadowed region, one of the most promising locations for water, ice deposits on the entire lunar surface. China's decision to place a seismometer there, just months before NASA's Artemis astronauts arrive with their own seismic instruments, is not a scientific courtesy. It is a positioning move in a competition that no treaty has yet formally defined, and no international body has yet successfully governed. The Artemis Accords, the framework NASA has built for international lunar cooperation, have been signed by dozens of nations. The Accords encourage the public release of scientific data and the preservation of historic locations like the landing sites of Apollo 11, recognizing them as areas of cultural significance requiring conservation. But the Accords are not a treaty. They carry no enforcement mechanism. They create no binding obligations around resource extraction. And China has not signed them. Russia has not signed them. The two nations most capable of competing with the United States for the South Pole are operating under no shared framework whatsoever. And beneath the geopolitical maneuvering, the scientific picture is assembling itself into something that researchers in 2026 are only beginning to articulate fully. Scientists now have a prediction for what to look out for. No one has physically measured the ice on the moon yet, but the groundwork has been established. Our findings are laying the groundwork for an observation we'll get in the next couple of years, said one of the lead researchers. The moment of direct confirmation, the moment when a seismometer or a drill or a neutron spectrometer finally returns data that says unambiguously, yes, the ice is here, this is where it is, this is how much there is. That moment will trigger a cascade of decisions in government buildings and corporate boardrooms that will make the space race of the 1960s look like a warm-up exercise. Because this time, the prize is not national pride. The prize is water. The prize is oxygen. The prize is hydrogen fuel for rockets that can go beyond the moon, to Mars, to the asteroid belt, to wherever the next frontier of human civilization decides to reach. The prize is the ability to sustain human life in space without the crushing cost of launching every resource from the surface of Earth. If water can be extracted and utilized from the moon, it could streamline the logistics of sending human missions to Mars by reducing the amount of water needed to transport from Earth, a potential game changer in terms of sustainability for long-term habitation. The moon is the gas station between Earth and everything else in the solar system, and right now, nobody owns it. These upcoming missions could deliver the first direct evidence that seismic exploration works as predicted, opening an entirely new method for resource prospecting on the moon. An entirely new method. Think about what that phrase implies. If seismic mapping can locate ice deposits beneath the lunar surface without drilling, if vibrations can be used to create three-dimensional maps of buried resources from the surface down, then the same technique can be applied across the entire moon. Every crater, every permanently shadowed region, every basin. The entire South Pole becomes legible in a way it has never been before. A geological map of resources drawn not with drill cores, but with sound waves bouncing through ancient rock. The consequences flow outward from this point in ways that are difficult to fully trace. Consider the economic dimension alone. The estimated value of water ice at the lunar South Pole, if the deposits are as extensive as current modeling suggests, runs into figures that make Earth's largest known mineral reserves look modest by comparison. Rocket fuel produced from lunar water costs a fraction of what it costs to launch propellant from Earth's deep gravity well. A cislunar economy built around lunar water extraction could reduce the cost of deep space missions by orders of magnitude. It could make Mars not just a target for heroic one-off expeditions, but a destination for sustained, systematic human expansion. And the nation that controls the extraction infrastructure at the South Pole controls the economics of that entire future. As part of a golden age of exploration and discovery, NASA announced it is increasing its cadence of missions under the Artemis program to achieve the national objective of returning American astronauts to the moon and establishing an enduring presence. Enduring presence. Those are the operative words. Not a visit, not a demonstration. An enduring presence, permanent, infrastructure, continuous operations, sustained human habitation. The kind of presence that, in the history of terrestrial exploration, has always preceded territorial claim, economic development, and ultimately geopolitical dominance. And the secrets that Artemis is uncovering beneath its surface, the mantle rocks, the ice deposits, the seismic map of a geologically active interior, are not just scientific discoveries. They are the intelligence report that precedes the occupation. Every data point returned by a seismometer, every sample analyzed for mantle chemistry, every neutron spectrometer, reading confirming the presence of hydrogen beneath a shadowed crater floor. These are reconnaissance findings. They are telling someone exactly where to go, exactly what to look for, and exactly why the South Pole of the moon is worth fighting for. The question that remains, the one that no press conference has answered, that no scientific paper has addressed, and that hangs over every Artemis mission announcement with the weight of historical consequence, is not whether water ice exists on the moon. The seismic data, the orbital observations, the neutron spectrometer readings, and the computational models have already made that case with confidence approaching certainty. The ice is there. The opportunity to verify these predictions may arrive much sooner than many expected. And when that verification comes, when the first seismometer at Shackleton Crater returns its first bounce pattern from a buried ice layer, when the first drill core from an Artemis astronaut's moonwalk pulls up frost-laden regolith from a permanently shadowed crater floor, the world will learn something that changes everything. Not just about the moon, not just about water, but about what humanity is actually doing when it says it is going to space for science, for exploration, for the benefit of all mankind. The real story is that we are going because someone has to go first. And whoever goes first and stays and builds and extracts, that someone will shape the next 500 years of human civilization from a vantage point that looks down on every nation that decided to stay home and watch. The moon is not a museum. It never was. It is a frontier with resources, strategic value, and secrets that 4.5 billion years of silence have kept perfectly preserved. Artemis has opened the door. The seismometers are listening. The gravity maps are revealing the outlines of buried ice beneath ancient rock. The mantle material is waiting to be collected by gloved human hands that will carry it back to laboratories where the chemistry of planetary formation will finally be read directly from the source. What happens next depends on decisions that have not yet been made publicly, by governments that are not yet speaking honestly about what they know, in a competition that has no referee and no agreed-upon rules. The moon is shaking, the ice is hiding, the mantle is waiting. And humanity, divided, ambitious, driven by forces both noble and nakedly strategic, is on its way back. The only question left is what we will do when we actually understand what we found.